Hey guys, welcome to our third video on graphing. In this video, you are going to learn about gradient and position time graphs. By the end of this video, you will be able to use position time graphs to construct velocity time graphs. So now we're combining our first two motion graph videos. So let's go ahead and start by defining the word gradient. So gradient is just another way of saying slope. So when you see the word gradient, we're going to remember gradient is the exact same thing as slope. And it's just important to be comfortable with both of those terms because you may see one or both of those terms in problems in the future. Now, when we construct a position time graph, so say this is my position time graph. I've got time and I've got in seconds and I've got my position in meters. And I'm going to just draw my graph as a straight line because this is what you'll be the most used to seeing. So if I were to find the slope of my line, I would need to figure out rise over run, right? So slope, m, is equal to rise over run, or is equal to my change in position over my change in time. Hopefully you guys recognize this because your change in position over time is just your velocity. You can also see that in the units, right? So we're measuring our x-axis in seconds and our y-axis in meters. So rise over run is going to have the units, meters over seconds, which is, of course, the units for velocity. So guys, the key takeaway here is that to go from a position time graph to a velocity time graph, all you need to do is find the slope of your graph. Now, this is a little easier said than done in that sometimes you'll have multiple slopes to find, but you guys know how to find slope, you guys know how to construct these graphs, so all you're going to do is figure out your slopes. So let's go ahead and do that. So here is our very first example. So we have our position time graph, and you'll notice I did not label this very well, right? I don't have labels on my x and y axis, but we're going to say, again, our x-axis is time, and our y-axis is, of course, position in meters. So what I'm going to do is I'm going to start by breaking my graph up into straight lines. So finding the slope of this whole graph is not really going to happen. But we can find the slope of this section because that's a straight line. We can find the slope of this section because that's a straight line. And we can find the slope of our last section. So I'm going to label them as 1, 2, and 3. So let's go ahead and start by finding the slope for section 1. And what I'm going to do is I'm going to pick 2 points on that line in section 1. And I'm going to go ahead and just pick the top and the bottom. I'm going to make this a nice blue color so that way it's a little different. So I'm going to say the slope at 1, so the velocity for section 1 is equal to rise over run. So it's going to equal my change in position over my change in time, or change in y over change in x if you're more comfortable with that. So I start at this point 0, 0, and I end at the point 2, 2. So I have my x coordinate, that 0 and that 2, and I have my y coordinate, also 0 and 2. So when I put this in my equation, what I'll get is that 2 minus 0 over 2 minus 0 is my velocity. So that the velocity for my first section, for my first 2 seconds, is going to be 1 meter per second. Now I'm ready to do my second section. So I'm going to pick 2 more points, and I'm going to pick, again, the 2 endpoints. And I do that just because those are the 2 really easy points to see. And so again, my first endpoint now is 2, 2. My second endpoint is going to be 6, negative 2. And it's important, guys, here to make sure you remember the order. So what my previous point 2 was, this guy, is now going to be point 1. And my point 2 is my new point. So what I'm going to say is that V2 is equal to, again, my change in position over my change in time. Or, another way I can write this, the position at my y value at my second point minus my y value at my first point divided by the time at my second point minus the time at my first point. And it's important to remember to keep in mind the order of these. So if I were to flip my first and my second point, my slope would have the wrong sign. And you can go ahead and try that and see, and you can see for yourself if that's something you'd like to do. So again, it's important to remember the order. So my second point is at the value 6, -2. So my position there is -2. And from that, I'm going to subtract my first point, which is at 2, 2. So my y value, my position, is 2. So -2 minus 2 over 6 minus 2, which are my two time values. So that gives me -4 over 4, or -1 meters per second. So for my first 2 seconds, I'm moving forward. And for my second 2, I'm going to be moving backwards. And you can also see that in the slope of the graph, right? My first section is going up the mountain and section 2 is going down the mountain. Section 3 is also moving forward, which means I expect my slope to be positive. So let's go ahead and find the slope for 3. So we've got our same point at 6, -2, and that is now going to be point number 1. And we've got our point number 2, which is at 8, 0. So 8 seconds, 0 meters. And I can find my last slope, V3. And that's going to be my change in position, again, over my change in time. It'll be S2 minus S1 over T2 minus T1, which you guys have seen in the past as Y2 minus Y1 over X2 minus X1. And we're going to put in our numbers. So we're going to say 0 minus -2. And again, we're starting with our second point here. So that's 0, this guy, minus that -2. And we're going to do figure out our run, what our change in x is. And that's going to be 8 minus 6. So what that's going to give me is 2 over 2, or 1 meter per second. One thing to remember here, guys, when you subtract a negative, it's the same as adding a positive. So minus -2 is the same as plus +2. So let's go ahead and summarize our results in a table. So for my first 2 seconds, so 0, 1, 2 seconds, that's my time, I am going to be moving with a velocity of 1 meter per second. And I'm not going to put my labels in, even though I know that that's bad practice, just to save a little bit of space here. So then I've got my next few seconds, so my 3rd, 4th, 5th, and 6th seconds, which is just going to be that total time that I spend in section 2. So I spend my 3, 4, 5, and 6 seconds in section 2. And for those, I'm going to put the velocity I found for that section, which is -1 meters per second. And then I have my last 2 seconds, 7 and 8, and I'm going to put in the velocity that I found for those last 2 seconds, which is, of course, that last 1 meter per second. So now I am ready to create my velocity time graph. And I'm going to start by just copying over my table. Okay, so to save you guys a little bit of time, what I did was I have written my table to the left, and I have constructed my graph on the right. And you'll notice, again, both my table and my graph have appropriate labels, units, and titles. So I'm ready to construct my velocity time graph. So for my first 2 seconds, I am at 1 meter per second. So first second and our second second, I'm going to put my dots at 1. And then for seconds 3 through 6, so really, again, remember I'm going to start at 2, I am going to be at -1 meter per second. And again, that's just the velocity that I calculated from the slope of my position time graph. And then for my last 2 seconds, so my 7th and my 8th second, I'm going to be back at not 0. So let me go ahead and undo that. I'm going to go back at 1. So here is my graph. And so what I've done, as you can see here, I have sections 1, 2, and 3 for my position time graph. And I have those same times labeled on my velocity time graph. But instead of showing my position, I'm now showing the slope of those graphs. I'm showing the velocity of my object during those times. So let's go ahead and talk about takeaways. So first of all, to go from a position time graph to a velocity time graph, so position to velocity, you need to find the slope of the graph. Second, breaking apart your graph into sections that are straight lines is a good strategy for figuring out your slopes and therefore your velocities. So go ahead and see if you can do this on your own. Try your very best, solve some problems, best of luck, and happy solving. And if you need to watch one more example before you feel comfortable with this, go ahead and watch the second example video on creating velocity time graphs and position time graphs. I know this is a hard topic. Some of you may feel comfortable with it already, but if you would like to see this done again, please go ahead and watch that second example video for a little bit of extra practice.